Good to see you all there. Very sad I can't actually be up there with you, but doctor's orders are doctor's orders. So I'm assuming some of you have actually seen me present on agroecology before, so I've taken a slightly different angle and brought in some different things here. So that's what I'm going to tell you today, and also about doing this yourself. And if I can get the right thing going, right, getting my Douglas Adams reference in early on. To me, having been in this space for some 30 years, agroecology, it's amazing how much it's really coming to the fore nowadays. So quick primer for those of you not familiar with agroecology and what it is. It's a difficult thing to explain because it's a big multifaceted beast. So we'll have a look at a few of those facets. So first up, it is a century-old science that started out by studying farming through an ecological lens. Why did it do that? Because our farms and orchards and vineyards, they are ecosystems and we need to manage them as such. So what is exactly then ecology? It's astonishing considering how big and complicated ecology is. Defining it is really simple and precise. It's simply the science of how species interact with each other and their environment. And out of that little concept, a vast amount of understanding and knowledge and science comes. So flipping it round, not only is it a science that studies farming through an ecological lens, it's also about doing farming and growing with an ecological mindset. So what is that mindset? Well, it's a fairly big, complicated thing in itself. But the key part of it is viewing the production system as a whole. With intensive agriculture, we've split it up, so we manage nutrients separately from weed management, from pest management. Agroecology, ecology very much views the farm system as an interconnected whole. And although it's got ecology in the name, it's actually much broader than the discipline of ecology. Its agroecology is far bigger than ecology itself. So it is a capstone science. Nothing sits above ecology, agroecology, everything feeds into it, including stuff like engineering, economics, history. So stuff you wouldn't necessarily immediately associate with it. It's really, everything is in there. And I often use the analogy in this space. Intensive agriculture and the ag chemicals are a bit like a tank. They're kind of big and powerful, but they're a bit of a one-trick pony. And as the Russians have discovered, it's surprisingly easy to disable and disarm and destroy a tank. Martial arts, the agroecology is more like the martial arts. You study your opponent's strengths and weaknesses, and then you target their weaknesses using an appropriate technique. Another way of kind of getting your heads around it, Steve Gleisman here is one of the kind of the gods of agroecology. He's been working in this in the area his entire life, and this is his recent 3rd edition textbook on agroecology. And just to highlight from the table of contents, you can see we start off by looking at all these different components, you know, the plant, wind, soil, even fire, because fire is an important component of many farm systems. Then we start bringing it together, this ecological perspective, environmental complexes, heterotrophic organisms. Then we start really getting into that system level stuff, populations, genetics, species interactions, diversity, energetics. How does energy flow through agroecosystems, for example, all the way up to landscape diversity, and actually then how to do it. And this to me was a bit of an epiphany I had about half a year or so ago. The EU's farm to fork strategy, which is their plan for agriculture for the next 10 years, is explicitly based in agroecology. The whole of the UN now is promoting agroecology. So something like the International Panel on Climate Change, if it's talking about farmers, it's saying we need to change to agroecological. The EU and the UN are the world's 2 largest supranational bureaucracies. They take a huge amount of evidence, discussion and debate to decide what to have for breakfast. So the fact that both of these bodies have shifted from intensive agriculture, promoting intensive agriculture through the 60s, 70s and 80s, and have over the last 3 decades transformed to now be promoting agroecology, speaks really loudly to me. So agroecology is also used as an umbrella term for many of the alternative agriculture, stuff like regenerative, organics, agroforestry, permaculture. These are all effectively sub-disciplines of agroecology. And it's also about system redesign. So Rod and Stu here published this paper on the ESR concept a quarter of a century ago, and it's now starting to get some significant traction. And I think this is a very helpful kind of way of understanding what needs to happen in the direction of travel. So we start with conventional production back in the 70s and the 80s, stuff like calendar spraying. The E in ESR is for efficiency. So in weed management, this might be something like site-specific weed management, or spot spraying, so using a green seeker, so instead of just covering everything with herbicides, you only have your herbicide being sprayed when there is a green plant present. Substitution is a lot of the time where organics has got somewhat stuck. Organics has substituted for mechanical weed control for chemical herbicide-based weed control, but it's often ended up at the same solution. I've spent 20 years perfecting mechanical weed control in organic vegetables, and we could have tens of hectares of monoculture vegetables against nothing but bare soil, which is not a good ecological outcome. Where we need to get to is this redesign. The R in ESR is redesigning the system, which is what we're doing with this project in citrus up in Gisborne that you're going to be going and looking at today. So this is two things. This is signpost to the destination and also a roadmap of how to get there. Because if you're still in the conventional situation, if you kind of go, oh, right, we're going to go straight to redesign, I can assure you it's going to go badly wrong. There is an awful lot of lessons you need to learn en route. So you very much want to treat this also as a roadmap. So you move from conventional into efficiency and from efficiency into substitution and then into redesign, because you need to learn those lessons en route. And we also talk about the toolboxes, and we use this also in integrated pest management, integrated weed management, etc. And a key thing with agroecology is, unlike organics, the ag chem, the synthetic nitrogen fertilizers are not prohibited, but they are considered to be tools typically of last resort. If you can't find a better, more biological or ecological way of doing something, you still have the chemicals as a backstop, which is the situation in regenerative agriculture, for example. So what I'm going to do is going to give you some examples of the different toolboxes or tools from the different toolboxes. And to extent, I've deliberately not put them or chosen ones from perennial crops, because I kind of want to broaden your horizon and just give you an idea of the diversity of tools that are out there. So first up, a physical approach from mesh crop covers, because I've spent a whole load of time using mesh crop covers very successfully to completely control psyllid on potato crops. So it's conceptually, it's like a fly screen for crop. You've got fly screen on your windows at home. You can open the window, but the screen stops the flies coming in. So it's a physical barrier. It's made out of high density polyethylene or polypropylene, so it's insanely strong. Developed in Europe and Israel back in the early 90s. So there has been a huge amount of this stuff now used across Europe and Israel and expanding globally, including here in New Zealand. So this is very well proven stuff. So this is kind of ready to roll technology. This is what it looks like close up. So literally just a simple square weave, and we've got a winged aphid on there showing you that it physically, it can't get through the holes. This is what it looks like at scale. In Europe now, the only way to control root fly on turnips and Swedes is mesh crop covers. There are no insecticides that can be used for controlling root fly on these now. And the phenomenal thing about this stuff, it will control practically any pest, both invertebrate and vertebrate, on practically any crop. And this stuff is actually not just being used on field vegetables now, it's actually being used across Europe for controlling pests on perennial crops like apples, because again, the insecticides are failing or have been withdrawn. Can you imagine a single chemical that would control practically every pest on every crop? Yeah, no. And if I'd certainly come up with it, I wouldn't be sitting here talking to you lot. I'd be sitting on my own private tropical atoll somewhere, nice and warm. Because you just simply cannot have a chemical that can do that, but we can do that with physics. So it shows you the power of some of these techniques. Again, so there's been this tipping point in the last couple of years due to the computer systems that drive the likes of Google DeepMind. What's happened is these robots are now able to identify every single plant in a paddock. then based on the fact that they know what the crop is and what it should look like, they can identify the crop plants, treat everything else as weeds, and then individually kill these things. And so there's some astonishing ways they're killing this stuff. They've got lasers, there's focused light, hot oil, all kinds of different stuff. And this is an example of one machine. This uses microjets of herbicide. So this is in the farmyard. It's going to take itself out to the paddock. These are the microdoses that apply tiny little spots of herbicide, and they're using an organic herbicide. This is celery as a crop. It identifies the crop plants. Anything else then gets microjets of herbicide. And so in theory, this can replace every weeding tool in the system that's currently being used, both herbicides, over-the-top herbicides, and mechanical weeding. But agroecology is actually deeper than that. It says, okay, we actually need to rethink the problem. And I did that recently in this paper for weed research. And I said, okay, things are changing in this space, as Jeff was talking about in the introduction. So we need to think what we actually mean by a weed. And it's astonishing. This has not actually been completely done. So what I pointed out is, in agroecological weed management, there's actually 3 types of plant in the field. There's the crop. Weeds are now defined as plants that are causing significant harm on the balance, because all plants have benefits. And I coined this term ali plantae, which is Latin for other plants, for all the non-crop plants that are not weeds. So what we need is this next generation of robots that will only kill the weeds and not the ali plantae. So leave these non-crop beneficial plants in the environment to provide stuff like ecosystem services. And so in this citrus project, we've got a living mulch dominated by clovers underneath the trees that will become invaded by grasses over time and real weeds. So we could have robots that could go through and basically individually identify plants we don't want in the living mulch and kill them off, so the living mulch can be maintained effectively forever. Here's another example of a living mulch, not just under perennial crops, but under annual crops, a classic of planting a clover under a maize, a sweet corn crop. Conservation biocontrol. So this is the focus of the citrus project. And this is about manipulating the environment. So it's actually ecological control necessary than kind of biocontrol, because we're manipulating different species in the environment and putting these plants in that are going to boost beneficial insects that attack the pests. And this was the late, great Steve Raston's speciality, and he was renowned for coming up with snappy acronyms, including the acronym SNAP, which stands for Shelter, Nectar, Alternative Host, Prey, and Pollen. So this is what we're trying to provide. That's not all a conservation control, but it's kind of quite a key part. And I want to give you this as an example as something completely different from perennials, but just to show the power of these agroecological and conservation biocontrol approaches. So this is the push-pull system from Africa. This is subsistence farming. So this is a long way from where you are in Gisborne. And maize is a really, really important food crop, but it's completely hammered in Africa by a stem borer caterpillar and a parasitic weed called Strigia. So the standard solution would be, well, let's get some insecticides and some herbicides in here. Well, the problem is it's a stem borer, so you need some systemic insecticides, so they tend to be the chunky stuff. And parasitic weeds are really hard to deal with because they're attached to the crop plant as well. So if you put herbicides on them, they will go into the crop plant as well. So these two pests completely decimate maize production in Africa. The other issue with pesticides in this space is these are subsistence farmers. Pesticides are expensive, they're an ongoing cost. They're often illiterate. Understanding of stuff like health and safety and PPE is often not great. So, you know, insecticides are not a great, ag chem's not a great solution in here. So what was developed in Africa is these plots are small, so they're tens of square meters, is they plant Napier grass around the outside. And this is far more attractive to the adult moths than the maize is. So they go into these, and these are called trap crops. But even better, when the caterpillars hatch and start feeding on Napier grass, it produces this gum which glues up the mouth parts and traps the caterpillars and kills them. So it's called a dead-end trap crop. It pulls the moths out of the maize and then terminates them. Genius. What they then do is plant desmonium, which is a legume between the maize plants. Desmonium produces volatiles that repel. This is the pushing the moths out of the maize, because the moths don't like these volatile chemicals. It's also a legume, so it fixes nitrogen, which is transferred to the maize, so you're getting free nitrogen fertilizer. And it also inhibits the Strigia parasitic weed from attaching to the maize roots by producing chemicals out of the roots, allelia chemicals. So you get suicidal. So you're not only stopping the Strigia attaching to the maize, you're also depleting the soil seed bank of the Strigia. So a really simple system, and this has revolutionized maize production in Africa. And it's also self-sustaining because the farmers just collect the seed every year from all 3 species and replant them next year. Something really interesting has come up recently in grapes coming out of their vineyard ecosystem project. So there's about 3 species of mealybugs on grapes, and there's 12 species of parasitoids that attack those mealybugs. So that's our kind of background scenario. Some of those were deliberately introduced. So the wine industry has only just, somewhat astonishingly, banned the organophosphate insecticides. And the last wine growers who were using the OPs were really stressed that the mealybug populations would just explode when they stopped spraying. What happened was the mealybug populations dropped, sometimes quite significantly. Because what was happening is the OPs are only moderately effective at killing mealybug, but they're really effective at killing the parasitoids. So they basically wiped all the parasitoids out. So the mealybug had no biological control going on. Once they stop spraying with the OPs, the parasitoids come back in and start reducing the mealybug population. What they also discovered in this project is white clover and hawksbeard, which is looks a bit like a dandelion. The mealybugs really like living on these. So the initial reaction was saying, oh, these things are alternative hosts. They're going to be, increasing the number of mealybugs in the vineyards. We need to get rid of them. Well, no. There was this really interesting example where there was a vineyard that part of this project had basically just stopped spraying herbicides, and so the undervine was full of all kinds of different spontaneous vegetation, including a whole load of white clover, because that's what you get in New Zealand if you stop spraying, and also hawksbeard. And then they decided to sell the vineyard, so they thought they should tidy it up. I think tidying up should be completely banned in production systems. So they sprayed out the undervine, and then they recorded 4 times more mealybug than the next reading across the entire 7 years of the project. So spraying out the white clover and hawksbeard had basically removed those as safe sites for the mealybugs, so they'd all gone straight up into the vines because it's the only thing left in the vineyard that they will eat. So I look at this and kind of going, these are not alternative hosts. These are what are called in conservation biocontrol a banker plant, a non-crop plant that's a host for the pest or a closely related species that allows beneficials to then also attack and host on the pest and keep their population at a low and below economic threshold level. So I kind of go, these things are not alternative hosts. These are banker plants. You actually want to plant white clover and hawksbeard in your vineyard to host mealybugs so you have lots of parasitoids and stop the mealybugs becoming a problem. Quick photo here. This is Matt in the photo here with a flowering strip from last year and a few of the beneficial insects we identified as part of the literature review that Jeff was mentioning earlier. The key thing is it's only a few fraction of a percentage of insects are actually pests. The vast majority of insects are just completely benign. They're doing nothing in terms of your crop whatsoever. And there's actually quite a large number, much larger number than the numbers of pests, that are beneficial and are attacking the pests. So we're needing to rejig the ecology in these places to boost these beneficials, which are then going to keep a lid on our pests. And so the system redesign stuff, this is what we're trying to do in this project. Although the focus is on insect pest control, we're trying to achieve a whole load of things. So what we did is we got rid of the herbicide strip or cultivation if you're doing it organically, and we put this diverse living mulch in, mostly clovers with taproots so they don't compete strongly with the trees and ideally give them some nitrogen. And then we've diversified the pasture in the middle with a multi-species mixture of grasses, legumes and forbs. And what that's doing in terms of these kind of multiple benefits, if you increase plant biodiversity, you will increase insect biodiversity, and then all the other biodiversity sitting on top of that. We're going to get pest management out of it. We're going to protect our soil, improve the soil health, nitrogen supply, as I just mentioned. And what we're trying to do here as well is not make a more expensive system. We're trying to actually make a more profitable system by reducing costs. If you're not having to spray herbicides and you're not mowing your grass strips all the time, you're not having to apply insecticides at the rates you had to previously, this is all reducing your costs, which is increasing profit. So from my view, agroecology is very much about having your cake and eating it, doing a Boris Johnson. And having a crack, just to finish off here. There's a key thing about ecology is everybody's mileage varies, because starting off, of course, there's different crops, there's citrus, there's grapes, there's apples, all the rest of it, summer fruit. You've got different soils and climates and objectives and management style. There are no one-size-fits-all solutions here. Well, I can tell you, if you go and apply 2 litres of glyphosate in 300 litres of water per hectare, you will kill all green vegetation. That's pretty much guaranteed. I cannot simply say plant this and it's going to work. So you as farmers and growers have to try this on your production units at home. The caveat on everybody's mileage varies is do not bet the production system on a new ecological technique. Even if the neighbour's been using it and it looks like it's working genius on their place, try small on your place to start with. You may not understand fully how they're managing that system, for example. The thing to make rapid progress is try lots of different plants, mixture species, all at the same time, so that you can expand slowly. And as Jeff also mentioned, Sally's been writing up a book about actually how to do your own trials. So there's resources out there to help you do this. And again, everybody who's done growing for any length of time knows stuff like yield goes up and down by 10, 20% year to year. So 1 year's results are not enough. And as part of the regenerative agriculture white paper that came out of our Land and Water Monarchy Whenua Land Care research, we did went and interviewed a whole load of regenerative farmers and said, right, what does this mean for you and how do you think about all of this stuff? So there's this report out there that you can grab a copy of. There's a link there and it's on the Land Care and our Land and Water websites as well. And they talk about this mindset and attitude, failure is part of the journey, question everything. So there's some really useful ways in that document to actually go and think about how you would reconceptualize what you're doing on the farms and vineyards and orchards. But the most important thing about this is do not just go home and tell your staff and the family, your partner and the kids or whoever will listen to you about all this kind of great stuff you heard here today, but actually do something. Nobody else is going to do this stuff for you. You need to actually go and start trialing this stuff. So go home and make a plan and start trying something. Thank you very much. Right, Jeff, do you want to give us a call and we'll take some questions for this?
Just a quick question with the practicalities of if you're doing under canopy or you're interplanting. When you've got pruners, mulching, pickers running through it, just do you sacrifice the row for the mulching of the prunings, or do you move it out, or, just the workings of that?
Yep. This is the why don't bet the farm on it, because you need to think through any management change in any production system will have flow-on effects. And if you're making bigger changes to the farm system, you will have bigger flow-on effects. So you need to think about all of this stuff and then work out how you're going to manage it. Sometimes the impediments that it throws up, or the flow-on effects are so big, you say we can't actually do this. Other times you say, look, well, there's ways we can manage this. And so it's kind of then going, okay, not being too precious about stuff. If you're kind of going, okay, I need to get a whole load of workers through my orchard vineyard, and I've got a 2 meter high cover crop in there, clearly the cover crop just has to go. So yes, work through those things. We are go. So roller crimpers. This is a roller crimper. this is another roller crimper, and I'll explain exactly what they do in a second. This is a very famous one because this is the one for the Rodale built in the States, and I'll talk about Rodale some more. This is the horse-drawn one. So these are in South America. This is a really cool, sorry, getting everything coming at me everywhere here. So you simply flip them over to transport them, but do note the really big springs on that seat in the top right-hand corner, because these straight-bladed ones vibrate like crazy, which is why this helical design was devised. Here's the really big stuff from South America. So it's not just horse-drawn, it's tractor-drawn down there as well, and really big stuff. And this is one in action. So it's mounted on the front of the tractor, and what they're used for is terminating annual cover crops. In this case, a really big, nice crop of rye corn, cereal rye, and then direct transplanting. So these have all come out of the arable space. And we can see here, kind of from the top down, very simply, just flatten the stuff and drill into it. So amazingly simple process, bit of slow motion here, so you can see just literally nothing but these things, crimping the stems as they get flattened, tractors over the top. The drill's coming through. It's actually got some cultivators on the front of the drill, which have all been lifted up out of the way, so they're not doing anything. And then it's got a disc drill that's just going to come into sight now. So there's the disc drill coming through, essentially kind of more pushing its way through the cover crop, because you'd certainly never drill through that sideways. Job's done. How's that? Instantaneous, cover crop terminated and crop planted. So this has been developed both in South and North America. The South Americans were well ahead of the North. They call their machines in Spanish roller faca. So if you Google roller faca, you will find a huge amount of stuff out there. Rodale Institute, which is the premier organic research institute in the States, they developed this, started developing this in the early 2000s. And Jeff Moyer did a lot of that work. He's now retired as the CEO. And the book over there on the right, that's the second edition. The first edition was called Organic No-Till, but this technique has proved so valuable that it's now being used widely by non-organic producers as well. So Ted Gornicki is an engineer with the USDA, done a whole load of machinery research and many others. So how does it work? Well, we simply don't know. I was hoping to do some research on the exact mechanism some time back, but never quite got there. So what's happening is crimper rollers will kill cover crops that won't be killed if you just put a flat roller or a smooth roller over them or mowed them. So it's not cutting the stems, it really does just slightly bend them, crimp them. So there's some kind of physiological effect. The thing is, it just works so well and everybody knows how to make it work that kind of the interest in working out the physiology has kind of been lost. But there are some very important caveats in this space. It will only kill annual species, not perennials. And it only works on some species, as I found out to my cost, having done some research, and I'll show you this. So it'll kill hairy vetch very well, but it won't touch common vetch with a barge pole. And it'll only kill plants when they're in full anthesis, which means they're fully flowering. What's happened in annual plants is switching from vegetative to reproductive growth is essentially a one-way street. And so when they are at full flower, gone reproductive, and then they're crimped, they kind of go, okay, we're just going to give up here. You can use it for other things, such as, if you've got some tall pasture and you don't want to mow it, but you need to get it out of the way because the workers have got to come through, it can be quite useful for things such as flattening pasture to get it out of the way. In terms of the species, it's not a big list. This is from the first edition of Jeff Moyer's book. So we've got some clovers in there. We've got some cereals. Foxtail millet and sun hemp are probably not terribly available in New Zealand. Buckwheat certainly is. And for me, all the stuff coming out of the ecology and the soil science is saying use diverse mixtures where possible. Kind of the more the merrier. So I did some trial work at the BHU here back in about a decade and a half ago now. So we had these mixtures: oats and peas, cereal rye, common vetch, faba beans, and Orion vetch mixture. We did put them in really, really late. Ideally, we would have been in March, which would have affected the dates. But the earliest we could get in to crimp these things was December and January. We used the Rodale crimper roller. What did we find out? We found out a lot. We basically made a load of mistakes. Getting crimper rolling to work, particularly when you're using it in an arable crop rather than where you're tending to use it in perennial crops where you just want to go cover crop and terminate it. There's quite a lot of moving parts here, and it's ecology. So people's mileage varies again. So the oats and the peas, they didn't have enough competition, and the oats actually started regrowing again, which was something of a surprise. The pure rye, it's a real big thug of a thing, and it's allelopathic. So we had great weed suppression, and it was completely killed by crimper rolling. And rye is one of the dominant species used for crimper rolling in the States. Common vetch, as I found, completely couldn't be killed by crimper rolling at all, while its cousin hairy vetch kills really easily. But it's great for weed suppression. The Faber bean, so this is just a broad bean, a tick bean, tall growth, but not as dense as rye, so the weeds weren't so well suppressed, but it's very easy to kill. The rye and vetch combined, exceptionally dense, very good weed control, but again, the problem is I had common vetch, not hairy vetch in there, so the stuff regrew. And there's quite a lot of stuff to think about in terms of what are the flow-on effects of using a cover crop and then crimping it. One of the things we had is a massive difference in available soil nitrogen. And we used the amount of clover and grass that came through the mulch after it had been crimped as an indication of what that was released. Because what's going on here, these things are taking up soil nitrogen, you're crimping them, all the nitrogen is then in the plants, in the roots and the foliage, and it's not going to be released until that stuff starts decaying. And indeed, there's a form of cover cropping called catch crops that are deliberately about trying to capture nitrogen, particularly over winter. So you can see here a quick chart of the different proportions of grass to clover, giving us an indication of how much soil nitrogen there is. You can see in rye, it's virtually entirely clover, meaning there's very little soil nitrogen there. Vetch is kind of the other way around, to not quite a great an extent. About the same time as I was doing this, guys were working on this in California to show you how much nitrogen can be taken up. They used a rye cover crop and then transplanted vegetables. So these are plants with a plug of potting mix on them. They all died. There was so little nitrogen left in the soil. So generally in perennial crops, you're going to be growing these down the alleyways. So not under the crops. If you grew these under the crops, you could be in deep trouble with these nitrogen catch crop type species. But even so, if they're just down the alleyways, your crop's roots are still going to be getting into that space. So what's really important here is actually matching the cover crop and the cash crops in terms of their nitrogen fixation. Even when you do that, early season nitrogen may well, be an issue here. In terms of what came through, is a couple of photos here. Our problem is our climate's too warm here for this, for mostly an arable technique, because we don't get winter kill of the stuff growing underneath the cover crops. So they all came through, but you can see here the visual difference between the beans and the rye. And also the amount of weeds that survive under these things. This may actually be a benefit in a perennial cropping system, because you go, okay, what we can use is a technique called undersowing. So you put your cover crop in, and then you sow through that emerging cover crop the subsequent crop that you want, maybe some pasture. So you could come through, crimp your cover crop, and then you've got pasture going to immediately grow up through it. So yeah, so you've seen that from the photos. Yeah, I've visited Rodale in the States in the middle of winter where they've been doing this technique. They apologized. They said normally we have several feet of snow here. The soil was frozen so hard I couldn't make a dent in it with my foot. So this is really, again, another example of trying stuff small and not betting the farm on it. This requirement to be full flower anthesis is a massive problem in arable systems in New Zealand using crimper roller, because often the things are just flowering far too late. We really want to sow stuff in September in Canterbury. We're crimping only in December and January. That mightn't be an issue for mid-row perennials in perennial crops, but you need to understand when that cover crop will flower, so you know when you can crimp it and terminate it, so it's not going to be a problem. Because clearly if these things are going to be only reaching flowering in December, you're going to be wanting probably to come through with some spraying and other equipment well before then, and then you've got this cover crop that's not going to be killed by crimping. Sowing rates. In arable, sowing rates are purely an economic decision. It's around multiplying seeds. people working in cover crops, you can double, even treble your sowing rates and still get more biomass. So particularly where you are wanting to create a mulch layer, you want as much biomass as possible. And the term used here in cover cropping space is a smother crop. Cover crops designed to produce very large amounts of biomass. And a final really important point, a lot of people, particularly in viticulture, are ripping up their pasture and planting annual cover crops, and some of them are being terminated with a crimper roller because they want to improve soil health. Unfortunately, it's completely the wrong thing to do. There's been a complete revolution in soil science over the last decade about how organic matter is formed, and it's not from residue. So the above ground biomass from cover crops, that decomposes within a few years and basically has limited impact on soil organic matter and soil biology. What it's now realized is up to 80% of soil organic matter, and the organic matter that lasts for centuries to millennia, is derived from exudates coming out of plant roots. So what you need to do is maximize the amount of living plant roots. And the problem is annual cover crops, their evolutionary strategy is to be a seed. So they put all their effort into above ground biomass that feeds into seed biomass. Perennial plants like pasture species, their evolutionary strategy is to be a plant. So they want to make sure they've got lots of resources. So they put 2/3 of their biomass below ground, and the roots go deeper than annual plants. And as it's root exudates that drive soil health and soil organic matter formation and soil biology, perennials are far better for soil health and organic matter and all the rest of it. And they're cheaper as well. An annual cover crop may last 3 to 6 months. So you've got to clear the ground, maybe cultivate, plant it, look after it, water it, terminate it. That's all time and money. A well-established, diverse perennial pasture will easily last 5, if not 10 years, if not more. So it's far cheaper. So unless you've got very specific reasons for planting annual cover crops, and there are some really good reasons out there, don't. And particularly if you're trying to improve soil health, do not put an annual cover crop in. Plant pasture and leave it to grow long so it can maximize its root biomass. Thank you very much indeed. And if there's any questions, give me a call.